Once again, very good evening, dear all students. This is the second lecture of RCC design. In this particular lecture, we cover the remaining important provision of Indian Standard 456 2000 codes. Student, you see that this is the 96 page number of Indian Standard 456 2000 code. In this particular page, that is Annex G, clause 3 8.1, moment of resistance for rectangular and T sections. Dear students, this is very important to understand while you design the RCC sections. Dear students, this lecture also help you to cover the objective of RCC. More than 50% question of RCC is directly asked from Indian Standard codes. So student, here how to determine the moment of resistance of rectangular sections, that is G 1.1 sections. Section without compression reinforcement means this section deals with the singly reinforced sections, means the reinforcement is provided only in the bottom zone. Here, how to determine the neutral axis. The section A determines the depth of neutral axis from the following equations, that is xu by d is equal to 0.87 fy ast divided by 0.36 fck into bd, where xu is neutral axis depth, d is effective depth, fy yield strength of steel, ast area of steel, fck characteristic strength, b and d is the corresponding width and depth. The student, if xu by d is less than the limiting value, then in that case we determine the mu, means ultimate moment of resistance, by the formula 0.87 fy ast d bracket 1 minus ast by bd into fck into fy. And if xu by d is equal to limiting value, means xu by d is equal to xu limiting, in that case we determine the mu limit by the following formula: 0.36 xu max by d bracket 1 minus 0.42 xu max by d bracket on bd square into fck. Student, if xu by d is greater than the limiting value, the section should be redesigned, means you have to calculate xu by d. If it is less than limiting value, then you follow the mu is equal to 0.87 fy ast into d bracket on 1 minus st into fy divided by bd into fck. If xu by d greater than xu limit, in that case we follow mu limit is equal to 0.36 xu max by d bracket on 1 minus 0.42 xu max by d bd square into fck, where x is equal to depth of neutral axis, d is equal to effective depth, fy characteristic strength of reinforcement, ast area of tension reinforcement, fck characteristic compressive strength of concrete, b width of compression face, mu limit limiting moment of resistance of a section without compression reinforcement, xu limit limiting value of xu. G 1.2 section with compression reinforcement. The students, this is the case of doubly reinforced section where additional reinforcement is provided in compression zone also. Student, you see here mu minus mu limit is equal to fck asc d minus d dash, where d is the effective depth of tension steel and d dash is the effective depth of compression steel. Students, that is the design stress in compression reinforcement corresponding to a strain of, you remember that this is very important, several times asked in objective, 0.0035 xu max minus d dash divided by xu max, where xu max is the limiting value of xu. AC area of compression reinforcement, and D dash depth of compression reinforcement from compression face. Then the total area of tension reinforcement shall be obtained from the following equations: AST1 plus AST2, means AST is equal to total tensile reinforcement. AST1 is equal to area of tensile reinforcement for a singly reinforced for MU limit, and AST2 is equal to ASC into FSC divided by 0.87 Fy. Dear students, these are the codal provisions you must underline. If you have a code in hard format, then you underline this, because this is very important while you design the reinforced sections. This is the very important things I have already covered. One of more important things regarding working stress, I will cover all those in that particular lecture, because after that I will directly go to the syllabus and start the chapter shear and bond and development length. But before that, we go through the code, and very familiar with code, because code is very important. Several times I told you, you must follow the codes, because without code you don't understand or learn the RCC. You just go through the code and learn and highlight the point whatever you have to need while dealing with the RCC design sections. So student, go through the some working stress method of design, which is very important while solving the problems and objective point of view also. Okay students, these are the code Annex B Indian Standard 456 2000 code, clause 18.2.2, 22.31, 22.7, 26.2.1 and 32.1, that is structural design working stress method. Students, this is the page number 80 of Indian Standard 456 2000 code regarding structural design of working stress method. That is already discussed in previous lecture in classrooms, but right now I am go through the overview of the working stress method of designs, so that you feel more comfortable while discussing in 4 lectures, 4th chapter of our syllabus, that is shear design and development length. So dear student, this is some overview of working stress method, like limit state method of design. That is the assumption at any cross section, plane section before bending remain plane after bending. Next, all tensile stresses are taken by reinforcement and none of the concrete except and otherwise specially permitted. Means कि जो सेक्शन है बेंडिंग से पहले भी प्लेन होता है और बेंडिंग के बाद भी प्लेन होता है. नेक्स्ट, जो भी टेंसाइल स्ट्रेसेस लिया जाता है वो reinforcement के द्वारा ही लिया जाता है. The students, that is the grade of concrete and that is the tensile stresses. Like that, for M10 grade 1.2, M15 grade 2, M20 2.8, M25 3.2, M30 3.6, M35 4, M40 4.4, M45 4.8. Dear students, that is the tensile stresses shall be calculated as Ft divided by AC plus M into AST. Ft is equal to total tension on the member minus pre-tension in steel. AC, cross-sectional area of concrete excluding any finishing material and reinforcing steel. M is equal to modular ratio, and AST, cross-sectional area of reinforcing steel. Hey student, bond stress for deformed bar. You see here, in the case of deformed bar conforming to IS 1786, the bond stress given in table 21 may be increased by 60%. मीन्स डिफॉर्म्ड बार के केस में हम लोग बॉन्ड स्ट्रेस को 60% इंक्रीज करते हैं. प्लीज नोट डाउन दिस इज वेरी इंपॉर्टेंट फॉर ऑब्जेक्टिव पॉइंट ऑफ व्यू ऑल्सो, एंड इफ यू हैव अ हार्ड फॉर्मेट ऑफ दिस कोड देन अंडरलाइन दिस. ओके, नेक्स्ट, दैट इज वेरी इंपॉर्टेंट, दैट इज द C. The stress strain relationship of steel and concrete under working load is a straight line. मीन्स इसमें जो स्ट्रेस स्ट्रेन रिलेशनशिप होता है वर्किंग स्ट्रेस मेथड के अंदर में स्ट्रेट लाइन होता है. एंड दैट इज वेरी इंपॉर्टेंट, द मॉडल रेशियो M has the value 280 divided by 3 sigma CBC. That is very important. While designing the working stress method, you must take modular ratio M is equal to 280 by 3 sigma CBC, where sigma CBC is permissible compressive stress due to bending in concrete in Newton per mm square as specified in table 21. Dear student, that is permissible stresses in concrete. That is permissible stresses in steel. You must read if you have a hard format of this, and if you not, please download this and go through the page number 80 and follow all of them. Okay student, that is increase in permissible stresses, where stresses due to wind or earthquake, temperature and shrinkage factor combined with those due to dead, live and impact load. The stresses specified in table 21, 22 and 23 may be expected to a limit of 33 into 1 by 3%. Wind and seismic forces need not be considered as acting simultaneously. The students, this table number 21, permissible stresses in concrete. Clause B 1.3, B 2.1, B 2.1, 2.2, B 2.3 and B 4.2, all values in Newton per mm square. That is very important. Grade of concrete, that is the permissible stresses in compressions, in bending and direct tension. For M10 grade concrete, that is in bending 3 and in direct 2.5. In M15 grade concrete, in bending 5 and in direct tension 4, same as M27 5, M25 8.5 6, M30 10 8, M35 11.5 9, M40 13 10, M45 14.5 11, M50 16 and 12. That is the permissible stresses in bond for plain bars in tension. For M15 grade concrete 0.6, M20 0.8, M25 0.9, M30 1, M35 1.1, M40 1.2, M45 1.3, M50 1.4. The student, that note is very important. The bond stress given in column 4 shall be increased by 25% for bar in compression. ये जो वैल्यू है बॉन्ड स्ट्रेस का, ये टेंशन में दिया गया है. अगर हमें कंप्रेशन में लेना है तो इस वैल्यू को 25% क्या करना पड़ेगा, बढ़ाना पड़ेगा. दैट इज वेरी इंपॉर्टेंट एंड प्लीज नोट डाउन दिस बिकॉज दिस इज आस्क्ड इन several competitive examination also and for SBTE objective point of view also. For bar in compression 25% value will be increase in tension. Okay, that is the important part of the Indian standard 456 2000 code. After these lectures, when we start the next lecture, in that particular lecture we will cover the objective of these 4 chapters. अभी तक हम लोग जो 4 चैप्टर कंप्लीट किए हैं उसमें जो भी ऑब्जेक्टिव है उसको हम लोग कवर करेंगे नेक्स्ट लेक्चर में. एंड आप देखना कि जो ये कोड था इससे डायरेक्टली कितने सारे क्वेश्चंस जो कि ऑब्जेक्टिव में डायरेक्ट पूछे जाते हैं. मैं बार बार कह रहा हूँ कि इस कोड को पढ़ना बहुत ज़रूरी है. एज सेम इफ़ यू वांट टू अंडरस्टैंड द कॉन्स्टिट्यूशंस देन यू मस्ट नो अबाउट द शेड्यूल, आर्टिकल्स एंड पार्ट. एज सेम एज if you want to understand RCC sections, then you have to read the code Indian Standard 456 2000. Okay, after that you will understand RCC. Otherwise memorize RCC but not understand. Okay, so please follow the same. तो स्टूडेंट अगले लेक्चर में जब हम मिलेंगे तो हम 4 चैप्टर जो अभी तक हम लोग कवर किए हैं, मीन्स पहला जो चैप्टर था हम लोग को बेसिक्स ऑफ आरसीसी डिज़ाइन आफ्टर सिंगली रिइंफोर्स्ड सेक्शंस, डबली रिइंफोर्स्ड सेक्शंस, ये सारे चीज़ को हम लोग जो ऑब्जेक्टिव है इससे रिगार्डिंग उसे हम लोग कवर करेंगे अगले लेक्चर्स में. अभी के लिए थैंक यू ऑल ऑफ यू, थैंक यू वेरी मच.